All right, guys. Is there a greatest common factor between these three terms?
Yes.
Well, 4x squared and 4x do have a common factor of 4,
Yeah,
but not the 1. So we don't have a greatest common factor. So we will put our two sets of parentheses with three spaces. Third term is positive, positive. So the signs are the same and match the sign of the middle term. And negative. Guys. Now we need to find the factors of the first and third term.
4 and 1. That's it.
So factors of 4 are 1 and 4,
2 and 2.
or 2 and 2. Now the factors of x squared are x and x. Now do we want to try the factors of 1 and, or do we want to try 1 and 4 or 2 and 2 first? 2 and 2. All right, factors of the third term. Factors of 1 are 1 and 1. All right, let's check and see if these are the correct factors. 2x times negative 1 is negative 2x.
They're not.
Negative 1 times 2x is negative 2x. And negative 2x minus 2x is negative 4x.
Wow, try to match me, I can't help. Somebody who's just calling.
All right, guys. Focusing.
Right.
Is that the correct middle term?
Yes.
So the correct factors for this are 2x minus 1 times 2x minus 1. Now, what's interesting about this here is those two sets of parentheses are the exact same, yes?
Yeah.
So if we wanted to, we can reduce it to one set of parentheses being squared. Because this here is what we call a perfect square trinomial. We can rewrite it as a single set of parentheses being squared. Questions on this here? We ready for the next one? 16b squared minus 40b plus 25. Is there a greatest common factor between these three terms? All right, guys, focus, focus. So we'll move on to our two sets of parentheses with three spaces. Our signs. The third term is positive, so the signs are the same and match the sign of the middle term. Negative. Now, factors of 16b squared. Well, we'll have b and b for sure. Now, factors of 16. 1 and 16, 2 and 8, 4 and 4. Which one of these factors do we want to try first?
2 and 8.
Huh?
No.
4? Yeah, you can grab one. Make sure to return it.
Better return it. Yeah, return it. Yeah.
All right. 116, 2 and 8, 4 and 4. Which one are we trying first?
2 and 8.
2 and 8.
Yeah, I thought Rick's gonna be right.
Factors of 25.
Hey, 5 and 5. 5.
All right, we'll do 5 and 5 first. 2b times negative 5 is negative 10b. Negative 5 times 8b is negative 40b. Negative 10b minus 40b is negative 50b.
Yep, I know what it is. It's going to be 4 and 4. Yep, and keep the 5s.
Okay. We'll switch the 8 and 2 with 4 and 4. Let's try this again. 4b times negative 5 is going to be negative 20b. All right, guys. Guys, focus. Negative 5 times 4b is going to be negative 20b.
Dude, I'm so smart.
Giving us negative 40b. guys. So 4b minus 5 times 4b minus 5, or we can rewrite it as 4b minus 5 squared. We look at some others, but really after this next one, it is pretty much the rest of this is patterns. We'll get to those. Those are new.
100? Oh, yeah, baby boy.
All right, guys, we're adding something to this here.
What the frick? Oh, yeah, that's the easy way.
Yeah, we're adding y.
I knew you were going to do that. I thought of that right as it came out. This is easy.
So this here actually doesn't change anything. So first thing we look for is the greatest common factor between 100, 180, and 81. And there's not one. So we'll move on to our two sets of parentheses with 3 spaces. Now the reason this still works is because our first term has an x squared, our second term has a y squared, and the middle term has an xy. It has to have each one to the first power in the middle, our squares on the side. Because if we had 100x squared, 180x plus 81y squared, it won't factor. We have to have the xy in the middle. Now the third term for here is positive, so the signs are the same and match the sign of the middle term. So we have plus and plus. Now we're not going to look at the whole first term yet, but the factors of part of the first term, our x squared would be what? X and x. Our third term has y squared, so y and y. Since x was in the first term, it goes in the first spot. Y was in the third term, it goes in the third spot. Now for our first term, because the middle one comes from our check. It does and doesn't. The middle term does matter, but doesn't matter at the same time.
Get out of here. Get out of your little turn. Like, 1 in 100, 2 in 50, 20 in 5.
Hey, how was doing? I like my basement. That's all in my inside. Maybe you do.
So factors of 100, 1 in 100, 2 in 50, 4 in 25, 5 in 20, 10 in 10.
Bingo.
Which one do we want to try first?
4 in 25.
4 and 25.
4 and 25. Me and Bella said the exact same thing. I did not.
Factors of 81, our third term, 1 and 81,
9 and 9.
3 and 27, and 9 and 9. Which one do we want to try first?
9 and 9. Since nobody else
Bless you. 4x times 9y. Well, 4 times 9 is 36. X times y is xy. That's where we get that xy, that middle term values. 9y times 25x would be plus 225x y.
Yeah, probably. Dude, I was literally just throwing out numbers.
So we have 261xy. And again, we need a place to start, so we have to pick one of them. Yes, sir. Yes.
I know which one it is.
So do we want to switch the...
We're going to have 5 and 20 on there.
So we switch the 4 and 25 with 5 and 20.
Wait, no.
Not, okay. 2x times 9y is going to be 18xy. Now 9y times 50x is going to be 450xy, which will give us 468xy.
Guys, that's not right. Okay, let's try 3 and 27. You're not saying nothing? Yeah, to be fair, you haven't said nothing.
I'm not allowed to get you.
That's not funny. What did Jay say? Jay's weird.
Oh,
That is right. Because that's 100, and that's 81 right there.
So 10x times 9y
Hey,
90xy. 9y times 10x is going to be 90.
That's what I meant.
That's not what. Oh.
90 plus 90 is?
You know what, JB? Whenever you stop.
All right, guys. Focus in. Focus in. Guys, side comments. Guys, focus, focus, focus. Up here. 10xy, 10x plus 9y times 10x plus 9y are our factors.
What a smart guy you are, sir. Did you hear her? Yeah, and he chuckled. He laughed about it? Oh, that's crazy.
Questions on this here?
Rumors going around about you.
Guys, side comments. Let's leave them. Guys, focus. Up here.
Sorry. I apologize.
Yeah.
Okay, Bryce, shut up.
Here's the next one we're looking at. N squared minus 25.
In and in. There's the factors in.
Now,
The third term is
It's 0.
is our 25. Now, the question is, does this follow our difference of perfect squares? Because our difference of perfect squares formula said if we have a squared minus b squared, it is going to factor to a plus b times a minus b. Where a and b are our terms, our first one, what multiplied by itself, gives us n squared, and what multiplies by itself to give us 25. Because our a squared minus b squared is our a plus b times a minus b. So to follow this pattern, first thing we need to find and see, is n squared a perfect square? And we rewrite it as something times itself. What times itself is n squared? Yeah, we can say n times n is n squared. What times itself is 25? So in this case, a is n, b is 5. So it tells us that this here will factor to n plus 5 times n minus 5. These are normally the ones that y'all like.
okay, so then
Yeah, the 2 things.
if one of those numbered like
No.
doesn't give a perfect square thing, then it just doesn't.
If one of them or both of them is not a perfect square, what I would look for is a greatest common factor.
If that's unfair.
Then it doesn't factor. Because the first thing I would say is if it doesn't, we don't have perfect squares, look for greatest common factor.
I want on here like that.
Let's see here. X squared
I'd like to see one.
plus, yeah, no, not plus. This isn't on the paper, but let's look at, say, this one here. 2x squared minus 18.
I know that.
What times itself is 2?
Wait, what?
What times itself is 2?
Wait, nothing.
Nothing. What times itself is 18?
No.
9 times 9?
I mean,
Oh, wait.
6 times 6 is 4 times 4.
I don't think that it's 16.
Because another way to check
Score is 16. Is the calculator.
is we can take the square root, because the square root is trying to find what number times itself.
I'm just trying to get the calculator.
What number will go into both 2x squared and 18?
2.
So what we can do is we can factor that out. And if I factor the 2 out of 2x squared, we're left with,
X squared minus.
if I factor 2 out of 18,
Okay, no, I thought that was
okay, let's check this again. What times itself is x squared?
X squared.
What times itself is 9? 3. So we could say that this is x plus what? Times x.
Sweet.
So even though the original problem wasn't set up as a difference of perfect squared, we pulled that greatest common factor out. We do have one, and we can go from there. Let's look at this one here. 16n squared minus 9. What times itself is 16? 4. What times itself is n squared? N.
Yeah, I was going to say in, but.
Yep. And then 3. So this is factoring to what? 4n plus 3 times 4n. Now the order in which you put these doesn't matter.
How does that?
Huh? That's as low as it'll go, because what times itself is 16n squared? Well, 4n, that's our a. What times itself is 9? So 4n plus 3, 4n minus 3. Now you could have written it as 4n minus 3 times 4n plus 3. Because again, multiplication order doesn't matter. Just need one of those two. Questions on this here? Now this step is just to help us see A and B. We don't necessarily have to write it. If we see A and B and can factor it, that's fine. 4m squared minus 25. You know what? Let's change. Let's add 25n squared. All right, guys. What times itself is 4m squared? 2. 2m. What times itself is 25n squared? So this will factor to what? 2m plus n times 2. That's it. Questions on this here? Any questions on difference of perfect squares so far? Yes. We ready to look at this with a higher degree?
I already know it. I know the next one.
Okay.
There's 2. It's a to the 6th power.
Because what times itself is a to the 4th? Well, a squared
See me, bro? I'm on fire.
squared, because a squared times a squared is a to the 4th. What times itself is 9? 3. So this time, instead of it just being a squared, we have a squared squared. Because instead of having a squared, we have a to the 4th. And our a squared squared is indeed a to the 4th. So this would factor to what? A squared plus 3 and a squared minus 3. So even though we're looking at a 4th power, we get this here. Now, since we have a squared at this point, we do need to make sure it doesn't factor. Because the reason the ones before this stopped, because the power to the variable was, here the power is. Now the a squared plus 3, we do not have a sum of 2 squares. There is no sum of 2 squares formula. It's imaginary, and here it's irrational also. We won't have a sum of 2 squares. Now this other one is a difference, but are both perfect squares. Well, a squared is, yes. Is 3 a perfect square? No. So that there is completely factored. Because if we had a squared minus another perfect square, we can factor it again. Questions on this here? We ready for the next one?
Yes, sir.
K to the 4th minus 36. Well, what times itself is k to the 4th? K squared. What times itself is 36? 6. So how does this factor?
A squared plus 6.
K squared plus 6.
K squared minus 6.
K squared minus 6. Now, since 6 is not a perfect square, we are done. The k squared plus 6 doesn't factor anyways. We don't have a sum of 2 squares. K squared minus 6 has the potential to be able to factor, but since 6 is not a perfect square, that's as far as it goes. Questions on these two here? Now the question is, what happens if it could? Well, let's look at this one here. X to the fourth minus 81. Well, what times itself is x to the fourth? X squared. What times itself is 81? 9. So this here will factor to what? X squared plus 9 times x squared minus 9. Yes. Is 9 a perfect square? 3. So that means that this second set of parentheses is also a difference of perfect squares, yes? Now we don't have a sum of perfect squares, so x squared plus 9 does not factor. But the x squared minus 9 does, because what times itself is x squared? X. And what times itself is 9? So this actually factors down further. So our x to the fourth minus 81, we can only do the second one because x squared plus 9 does not factor. I mean, we can technically factor it, but to be able to factor it, you would need to know the solutions. Because perfect square means that there is a number times itself that would work.
If it was like 10 and 5 that would work.
Because 9 is 3 times 3. But there's no way for us to factor this and get that middle term to cancel out. Because really the only way that it would work is using 3i and negative 3i. Because essentially we solve it to get there. Because if we use those, x times negative 3i is negative 3xi plus 3xi. These would cancel, but then the I squared would help us get back there. But those are imaginary factors. That's not factoring. That's set apart. We only look for real factors, real rational factors. We don't look for imaginary or complex. So this is as far as we can take this. Questions on this here? All right. Sum and difference of two cubes. Now the sum and difference of two cubes follows a specific pattern for how this works. Now the first thing we do is find A and B, because this here is the sum and difference of two cubes. So our two terms are perfect cubes, a number or term that's multiplied by itself 3 times. So we can take the cube root to find those terms, those values. The other thing that's nice, and it's not obviously apparent until we look at it, here we are talking about a sum, yes? The signs for this here are going to be the same, opposite, always end on a positive note. Okay, that's cool. Whatnot. Let's look at the next one. So it's a difference. Same, opposite, always end on a positive note. So the sum and difference of two cubes, to keep the signs straight, is going to be the same, opposite, always end on a positive note. Keep the same sign, flip it, always end on a positive note. So no matter which one we do, we will always have 2 plus signs and 1 minus. It's either going to be plus, minus, plus, or minus, plus, plus. Does that kind of make sense? Now for the powers, well, in the first one, we have our first term, second term, AB. In both cases, it's AB. In the bigger one, We have a to the second, a to the first, no a term, really a to the 0. B, no b term, b to the first, b squared. So the power of b is going 0, 1, 2. The power of a is going to 1, 0. Does that make sense? So in the bigger set of parentheses, the power of a is going down, the power of b is going up. Questions on this so far? Oh yeah, we got plenty of time. 136. So when we go with factoring these here, let's look at this first one. So we want to get these a and b terms to kind of fill in the pattern. We want to see, can we take the cubed root, or see what times itself 3 times is x to the third? Well, that would just be what? X. Now we also need to see what times itself 3 times is not 135, 125. Or in other words, the cubed root, 125, is 5. Because 5 times 5, 5 squared is 25. 25 times 5 is 125. So that tells us 2 things. One, that both of these are perfect cubes. And since we have the sum of 2 cubes, we can factor this. Now the next thing we need to do is set up our parentheses. And the way I've always thought of these 2 sets of parentheses is the tractor trailer. Because we have the cab, the first set of 3, trailer's a little bit bigger. Set of parentheses with 3 spaces, set of parentheses with 5.
How do we get to this point, dude? I'm so
So, first thing is determining if it is 2 cubes. So we can take the cubed root of each and see if we do have perfect cubes. Cubed root of x to the third is just x. Because x times itself 3 times is x to the third. Cubed root of 125. Well, we can actually do this one in the calculator. Because we can do 3. Well, try this again. 3. Cubed root 125 is 5. So it tells us that we do have 2 perfect cubes, and since they're being added together, we have a sum of 2 cubes, which is factorable. Now the way we set up the sum or difference of 2 cubes, the first one will have 2 terms and a sign, so 3 spaces. The second one is going to have 3 terms and 2 signs. So that's where we get our 3 and 5, this tractor trailer. Any other questions on this so far? All right. Guys, focus up here. Guys, focus. The signs are going to be the same. Opposite always end on a positive note. So since we're talking about a sum, so the same would be plus. Opposite would be minus. Always end on a positive note. So we have plus, minus, plus. Questions on this so far? Now let's focus on our first term. Now our first term in this case is x. That's our a. So in the first spot in the smaller set of parentheses is just going to be a, so x. In the bigger one, in the first spot, we're going to have our a squared, which is our x squared. In the middle spot, we'll have x to the first, because it's going to go squared, first, no x term. So the bigger one, it's squared, it's to the first, we don't have it, or it's to the 0. Questions on this so far? So what we've done is I'll write this underneath, because what we're following is our a plus b, a squared minus ab plus b squared. We're just filling in a, because a in this case is our x. So we replace this a with x. We replace this a squared with x squared. Our a to the first is replaced with x to the third. In the middle, yes. Because it's a to the first, b to the first.
Okay, that's what I was lost. I was like, how did I?
And then the last one is really a to the 0, but anything to the 0 is 1, so it's not there. Now our b, in this case, is 5. So in the first one, we'll just have 5. Now in the first spot in our bigger one, we don't have a b term. It's really to the 0. So it's not there. In the middle, it's going to be 5 to the first. And our last one, it's going to be 5 squared. So in the bigger one, that really is we're doing b to the 0, b to the first, b squared. Its exponents are going up. A's are going down. Any questions on how we set this up so far?
I thought you were supposed to say any questions.
Any questions on how we set this up so far? So we have one last thing to do. Is simplify. I'm going to erase this here. I'm going to try to erase this here. There we go. Now the x plus 5 doesn't need to be simplified. That is as simplified as it gets. Now our x squared is just going to be x squared. We have to simplify. We multiply it by itself. It's just x squared. If it was 2x, we'd have to square both terms. In the middle, minus x times 5 is 5x plus 5 squared. And that's it. With the sum or difference of two cubes, that quadratic, that x squared minus 5x plus 25 here, will never factor. Its factors are going to be imaginary or possibly imaginary and irrational. So if there were factors, they would be irrationally imaginary factors. We don't do those. We just focus on the real factors. So this is as far as it goes. We will finish this tomorrow.